All right, this is your last set of notes on the circulatory system, so the heart part four. And looking at capillary fluid exchange. Okay, so some things that we'll go over today. Okay, so what you're expected to kind of know and what you'll be tested on Tuesday. So explain how matter is exchanged through the capillaries. Describe how the capillaries help the exchange of matter in the digestive system, respiratory, and excretory system, and explain the general function of the lymphatic system. Okay, so capillary fluid exchange. It's estimated that nearly every tissue of the body is within zero point 0.1 millimeters of a capillary, so a tenth of a millimeter of a capillary, so fairly close. Capillaries provide cells with oxygen, glucose, amino acid. Again, like everything when we're digesting it, all of those different things go into our bloodstream, and then through our blood, they're taken to all of the different cells. Okay, they're also involved in fluid exchange. Okay, so most of the fluids can diffuse through the capillaries. Okay, two forces that regulate the movement of fluid between the blood and extracellular fluid, so that's the fluid inside the cell. Okay, the two things that regulate that is fluid pressure and osmotic pressure. So we've talked about like osmosis, so that's kind of our water pressure, and then fluid pressure with that. Okay, there is reservoir of blood in the arteries creates pressure on the inner walls of the capillaries, okay, which is much lower pressure is found in the ECF. Okay. Water moves from high pressure in the capillary to low pressure in our extracellular fluid. Capillaries are selectively permeable. So proteins, red blood cells, white blood cells, they all stay in a capillary. They don't cross into the cell. Again, selectively permeable, we talked about that when we talked about the cell last year. Okay, it only allows certain things in and out. So our red blood cells, our proteins, all the kind of these bigger things, they stay in our blood. Okay, but the oxygen, the proteins, all those other things that are needed in the cell, the glucose, also those can diffuse across. The movement of the fluid out of the capillaries needs to be balanced with the force that moves the fluid in. So osmotic pressure draws the fluid back into the capillary. This is called absorption. So absorption depends on the proteins, the dissolved solutes that are found in our capillaries. The concentration of these solutes can change the rate of absorption. And so just looking here, so our arterioles, arteries lead into our arterioles, okay, which then this is our capillary bed. Okay. As the fluid pressure increases, the osmotic pressure in the cells comes up to kind of match it. Whoops. Okay. And then as it goes through into the veins, okay, the osmotic pressure stays the same, okay, but the fluid pressure decreases, okay, so we can get that absorption. Okay, the balance between osmotic pressure and fluid pressure is upset during a hemorrhage. So a hemorrhage is excessive bleeding in an area. Okay, the decrease in blood volume lowers the blood pressure. Okay, proteins as well as fluids are lost. Although proteins are lost, the concentration hasn't changed, so osmotic pressure doesn't change. The force drawing the water from the tissues to the extracellular fluid is greater than the force pushing the water from the capillary. So the water moves into the capillary, and then the fluid volume would then be restored. Individuals who are starving often show tissue swelling, so edema due to the water entering the tissue spaces. So you've probably seen this if you've watched like those commercials of the kids in Africa that have kind of the bloated stomachs. It has to do, they're starving, but they got the swelling due to water that enters their tissue spaces. Plasma proteins are often one of the last sources of energy, and so this decreases the osmotic pressure in the capillaries. Okay, so with a hemorrhage, okay, you get low fluid pressure, okay, and normal osmotic pressure. Okay, when you're starving, you get normal fluid pressure, but low osmotic pressure. Okay, and then we get for inflammation, okay, normal fluid pressure, low osmotic pressure, and so it'll start to inflame the area that might be hurt. Okay, our lymphatic system works along kind of with our circulatory system. So a small amount of proteins leak from the capillaries into the tissue space. Okay, it's a really slow leak, but if the proteins build up, it changes the osmotic pressure. Okay, it would start to decrease, and then the tissues can start to swell up. Okay, so to kind of get rid of those proteins, okay, these proteins are drained from the extracellular fluid and returned to the circulatory system through the lymphatic system. A lymph is a fluid similar to blood plasma. It's found in our lymph vessels, which are separate vessels. It's a low pressure return system, operates by the slow muscle contractions against the vessels, similar to how our veins work. They contain flap-like valves to prevent backflow, again, similar to veins. Lymph is returned to the venous system at the left and right subclavicle veins. The enlargements called lymph nodes are located at different intervals along the lymph vessels. Okay, these house the white blood cells that we'll talk a lot about next in chapter 12 that help with the immune system. The lymph nodes also filter out damaged cells and other debris, and they store the lymphocytes, which again are white blood cells that produce antibodies, which again we'll talk about in chapter 12. So when we get sick, our lymph nodes start to swell because of the increase in white blood cell production and filtration. A red bone marrow is where all types of blood cells are produced. Stem cells that are found in the red bone marrow, they are what differentiate into different types of white blood cells to meet the need of the body, depending on kind of like if we're going through infection or not. That'll change what the stem cells produce. So in children, red bone marrow is found in most bones. In adults, the red bone marrow is only found in the sternum, the cranium, ribs, spinal column, and the long bones of the legs and arms. Okay, the spleen is the largest of the lymphoid organs. Okay, the spleen is richly supplied with blood sinuses, which allow the spleen to hold about 150 milliliters of blood, okay, which then releases blood in response to a low blood pressure. The thymus gland, okay, found in the front of our trachea, is where the T cells mature. Again, talk more about T cells in the next unit. Okay, so just kind of a picture showing our lymphatic system. And so it has these different vessels. Here's our spleen, our appendix, okay, the bone marrow and our long bones. And then these are the lymph vessels. The thoracic duct is kind of the middle collection site of our lymph. And we have different lymph nodes, okay, throughout our body.